So I think this is a great question of what are melanocytes. So in terms of tanning, melanocytes are actually the cells inside of our skin that produce the tan pigment. And this pigment is referred to as melanin, and it's made out of the amino acid tyrosine. So the outermost layer of our skin is referred to as the epidermis. And it has a few different types of cells, but the two we'll focus on are keratinocytes and melanocytes. So the layer of cells closest to the surface of our skin are typically going to be made up of what are called keratinocytes. And when light from the sun or other UV radiation penetrates our skin, this radiation can actually damage some of the DNA inside of these cells. And the way these cells respond is actually really cool. So they go through what's referred to as a cell danger response. And this causes the production of a protein called P53. And this protein is referred to as a transcription factor, which means that this protein will actually bind to our DNA and cause specific genes to be transcribed and the production of certain proteins. And in the scenario of UV radiation, will produce a very large protein called pro-opiomelanocortin. And this is abbreviated as POMC. And like I said, this is a large protein that doesn't have much function in and of itself. However, what the body does is it kind of chops this big protein up into different molecules that are a little bit more effective. And inside the keratinocyte, it will chop this pro-opiomelanocortin molecule up into what is called alpha melanocyte stimulating hormone and beta endorphin. And this is why you may have heard me mention in the past that there is a mechanism that humans can get addicted to tanning, because the process of tanning will upregulate the production of beta endorphin, which is our body's natural opioid. But in terms of the melanocyte, the big thing we're going to be focusing on is the alpha melanocyte stimulating hormone, and you can probably guess what it does. So underneath the keratinocytes, deeper in the skin, we have what are called melanocytes, and these are the cell types that will produce melanin. And this may leave you scratching your head a little bit about why we don't just produce the melanin inside the keratinocyte. But if you think about it, it's actually kind of smart. The production of melanin is upregulated by DNA damage. So if the portion of the DNA that gets damaged inside the keratinocyte was the portion that allowed it to produce melanin, then we wouldn't be able to produce melanin in response to UV radiation. So instead, we outsource the production of melanin to cells that won't have DNA damage. And these are the melanocytes. So alpha melanocyte stimulating hormone binds to a receptor on the melanocyte. And this is referred to as a G protein, meaning that the alpha melanocyte stimulating hormone doesn't actually enter the melanocyte. Instead, it just binds to its receptor and it causes a cascade of proteins to upregulate inside of the cell. And for us, the most important ones are also transcription factors. And these transcription factors, again, bind to the DNA and increase the production of specific proteins. And I'm going to include a graphic on here because this is the part where it can get a little bit confusing. So inside the melanocyte cell, we have secondary structures referred to as melanosomes. And these are just small organelles that contain the tyrosine. And you can think of tyrosine as the inactive form of melanin. And this is smart, again, because it means that we're not producing melanin when there is no damage, and we're not just tanning unnecessarily. But when we get the cascade from the cell danger response that I described, this alpha melanocyte stimulating hormone will increase the activity of the specific transcription factors that encode for the enzymes to actually turn the tyrosine into melanin, and other processes involving replacing the melanosomes that we're using for melanin production. So the next time you're exposed to UV radiation, you'll still have these melanosomes present. So now that we have melanin inside of the melanocytes, which remember are at the deepest layer of the epidermis, we need to transport this melanin to the keratinocytes where the damage has occurred. And luckily, these melanocytes have projections referred to as microtubules. And these microtubules will actually connect to the keratinocytes. And they act almost as a conveyor belt, bringing melanin from the melanocytes into the keratinocytes. And now the final thing that occurs is that this melanin will surround the nucleus, which is the organelle that contains the DNA. And it acts almost like an umbrella. And it will absorb the sunlight and just emit it back into the environment as heat. Meaning that the next time we get exposed to UV radiation, we're less likely to cause DNA damage. And the last note I'll leave you with is this is why a lot of people who lived very close to the equator developed adaptations in which they produce a lot and a very dark pigmented melanin. Because unfortunately, the people with the genetics to not produce as much melanin to protect them from DNA damage from UV radiation were not able to survive as long in an environment with a lot of UV radiation. And this is the process you learn in biology of natural selection, but it's probably a topic for a different day. With that being said, I hope you enjoyed, and I hope this clears some things up. And if I missed anything or you have any questions, just let me know in the comments.